It's 2 o'clock, so we will get started with our focus on fractions continuing today. We're glad you're with us. And my name is Lisa Riggs. As Kelly said, I am a regional consultant with Kentucky Center for Mathematics, located in Central Kentucky. And for those of you that may be new to us, just a reminder that you can find us on the web at kentuckymathematics.org, and there you can find our virtual PD site where there's a link to our upcoming sessions. This week we'll be finishing up fractions. Next week is geometry, whoop, whoop, and then more multiplicative thinking after that. So for today's agenda, we're going to just dip into the research that we have been reviewing all week, take a look at what standards we're touching on. I'm going to share some activities and some resources with you guys. So we'll have some fun with fractions today. Okay, so here's a little activity that we've used in some of our sessions, and it's called always, sometimes, or never. So the statement below, I'd like for you guys to decide, is it always true, sometimes true, or never true? And you can think about this in two ways. How would you respond? And also, if you presented this to your students, how might they respond? Okay, to the statement, to add or subtract fractions with unlike denominators, you must find a common denominator first. So just, you guys can respond to that in the chat. And we're going to, after our presentation, we'll circle back to that in a little bit. So everybody kind of get your opinion. And I'm going to continue on. Maybe. Oh, my PowerPoint's just a little glitchy. Sorry about that. Okay. So our research is from the IES practice guide, which we've referred to all week. And there is a link in this presentation, as there have been in our prior presentations this week, which is the clearinghouse, from the What Works Clearinghouse. So, and we have taken a look at recommendation 1 on Monday and recommendation 2 on Tuesday. Today we'll be focusing on recommendation 3, as we did yesterday, working with those operations. So that IES recommendation is recommendation 3, tells us that helping students understand why procedures for computations with fractions make sense is one of the effective strategies for teaching fractions. So that is going to be our focus. So one thing that resonated with me with that statement is something I heard Greg Tang say a few years ago at our KCM conference. He was one of our featured speakers. And I had written this down in my notes. And I just took a picture of it so I had it and wouldn't lose it. But if you guys know Greg Tang's work, he writes books and uses a lot of poetry. So I thought this was very poetic and stuck with me. It said, concepts before conventions, reasons before rules, make sense before symbols, learn before labels, and knowledge before notation. So that really resonated with me. It's not that we don't do those things. It's not that we don't do conventions or rules or symbols and labels and notations, but we have to lay those basic foundations first so that those things make sense to kids. So I thought that was a nice quote. Okay. The standard we're going to be focused on today is that 5th grade standard 5NF1 to efficiently add and subtract fractions with unlike denominators, including mixed numbers. Okay. And the Kentucky standards have 2 bullets under that, which if we stop at there, we might have the connotation that comes to mind that we are thinking about rules and procedures and all of those things. But the 2 bullets under that tell us that we want kids using reasoning strategies, such as counting up on a number line or creating visual fraction models to find those, to add and subtract, and finding common denominators. And so, and thinking back to that statement at the beginning, that might be giving us a clue about that. Okay. So here's a little activity from the Howard County Public School Systems site, which will be linked in the presentation, that has to do with Hershey bars. So what do you notice about these things? And I do need some people to unmute and kind of talk because I can't see the chat. So what do you guys notice?
And if you put it in chat, I will telescope it out for you guys.
All right, thank you so much, Dee.
Well, I noticed that the sections are in groups and we have rows and columns.
Awesome. So if we think about the first one as one whole, what might we say about some of the other pieces?
That is one of the things that was in the chat, just for your, basically the idea of what is a whole. So is it different if each candy bar is its whole? So people did tie into sort of that. Just wanted to let you know that.
Yeah, good job, guys.
I was gonna say the one that's to the right of the whole candy bar is like you're adding 2 parts of that whole candy bar to get a whole, but down at the bottom you don't have the whole candy bar, but you still can add them together to get the other one to the right.
Okay, there we go. So yeah, so we see that if we put these things together, we can see fractional parts. So what might we call this fractional part? If we call it that piece?
1/3.
Yeah, there's 1/3. So that would be 1/3 of the whole. What about if we had this section?
2/3.
2/3. So if we could put it back together, we could add those 2 together. Okay. So what if we had these 2 parts? What might we call that?
3/4.
Okay, how did you arrive at that answer?
The one with 6 would be half of the candy bar, which would make the one with 3 1/4 of the candy bar.
Yeah, so this part would be 1/2 plus 1/4 gives us 3/4. So we were able to put those 2 together, okay, and come up with our total. And I don't know about you guys, but working with candy bars kind of makes me a little hungry looking at that chocolate.
There is a Hershey's candy bar book that I have used that does all kinds of weird things with doing fractions.
Yeah, it's nice how it's segmented into those sections, which you can break apart and think about. So how many number sentences can you come up with is another prompt that we can give students. So just in the chat, you might want to type in one that you could come up with these fractional pieces or parts. What might be a number sentence that you could create or that students could create based on what you see?
In the chat, we've got 1/4 plus 3/4 equals 1.
Okay, and this being a fourth.
Yep.
And 3/4, so we put it back together to make the one whole. Thank you.
We have someone who did the 1/2 plus 1/4 equals 3/4 from our example.
Nice. What would just one little square be? Or rectangle, I should say, to be mathematically correct.
1/12.
Yeah, 1/12. Okay. So if I could limit myself to one little rectangle, I would be eating 1/12 of the candy bar. So there's an activity that you can think about with students, and they can add and even subtract using that as a model. Okay, and I believe we talked earlier in the week about how, I think Leah mentioned this yesterday, area model, thinking about the measurement of the candy bar. So this is showing kind of that area of the candy bar and thinking about how we can add and subtract within that model. Okay, so nice. So there's one setting that we can use to help students to have context and to have a model as well, and a model that they're familiar with. And if you were using this in the virtual world, you might use something like this. If you were able to be with your students firsthand, you might be able to actually use candy bars to think about it. Okay, there we go. Another awesome resource that I have seen teachers use in their classroom. I actually got to see this in action in a classroom this year, which was a lot of fun, is the book Picture Pie. I don't know if you're familiar with it. And there is included in your resources, there is this worksheet for Picture Pie, which gives the kind of the directions for the activity. It's from K5 math teaching resources, but it uses the book from Ed Emberley. And I think you can, if you don't have access to the book, just Google it, you can find it pretty readily. But as you read, the students use fractional parts of a circle to build different pictures. And then from there, you can use that context to do lots of different things with fractions. So we're just, I actually took some pictures while I was in that classroom, and I have a couple of those up on the screen, which we're going to take a little bit of a closer look at, some student work. Okay. During the lesson that I was actually there, they were just beginning this activity. So they created their pictures and labeled their fractions. The teacher was going to circle back to it the next day and talk about, adding those fractions. So what might be some things that you could pull out from this picture of the bunny and the ladybug?
So Cindy, a couple people put in the chat. Oh, now it's moving fast. I love how we can see the 1/8 plus 1/8 is the same size as the 1/4. You can see that in the picture. And Jennifer goes on to expand that to, you can actually see that the 1/4 plus 1/8 plus 1/8 equals 1/2, because you can see that as well.
Right, and you could ask your students to give you the total for just the one animal or picture that they made, or give you the total for the whole picture that they created and made a scene.
Yeah, and from the chat, they said the bunny is 4/8, which would be the same size as the ladybug.
Right, and if we put the two together, what do we have? One whole circle. What about if we were taking a look at the bird? Any observations about student work there? I will say that I can recall actually asking the student that had created the picture of the bird what the total was of her bird. What would be the fraction added together, and she was able to explain it to me. She knew that the 1/2 plus the 3/8 would be 1/8 less of the whole circle, was the way she articulated it. So I thought that was some good reasoning on her part. So we were able to, and the teacher, when I spoke with the teacher after her lesson, that was what where she was heading to next, was to have them write some equations that illustrated what they had created. So
we have a number sentence that just got typed in. 1/2 plus 1/8 plus 1/8 plus 1/8 equals 7/8. And so you can see that in that image.
you can. Yeah. So there's lots of places you could go with that resource. And I will tell you, seeing the kids working was awesome. When I was in that classroom, I wish I had video of it, because the kids were talking to each other. There was a lot of mathematical discourse, trying to decide how to use the pieces and what the fractional parts were. And there was just a lot going on, and the kids were actively engaged. So it was a nice lesson. So that will be linked in our handouts as a resource that you guys can use for adding fractions of unlike denominators in a nice context. Okay. Another resource that I found for you guys is from Investigations. And let's see, I think this is a link to that, which will open up and give us a virtual. So I hope you guys can see that. I think you should be able to. And when you go to this site of Investigations, there is a drop down that tells you the directions for the game. Okay? And there is also a link to the worksheet is there as well. And this is in the handouts. So you don't have to get it there, but you can. But the directions, before you start this game, you need to have that worksheet to record thinking, but we're going to just go through it just a little bit so you'll understand how it works. Students place a marker on each of the number lines. So we can just drag our marker and put it anywhere we want as long as it is less than 3/4. So I could put it at 1/3. And the goal is to add your numbers together to get to 1 as your total. Add or subtract your numbers together to get to 1. So I'm just going to put these on here for purposes of demonstration. And we'll do a few. So when you take turns and you flip a card over, we have 3/3, which is the same as 1 whole. So what might we do? As it says in the examples, you don't have to use it on just one line. We could split that up and use it in multiple lines if we wanted to. So does somebody want to tell me how we might want to move those counters? Nobody wants to take a guess. Okay, so how about if we said we want to move 1/3, 2/3, that would put it in my collection box. Now, how much do I have left to go? If I'm doing
You've gone 2/3, so you have 1/3 left.
I have 1/3 left. So if I don't have any more thirds, how could I get 1/3, you think?
How about the 6th?
How about the 6th? How many 6 do I need to go, Cindy?
2 6ths.
I can move 2 6. So on my paper, I would write 3/3 equals 2/3 plus 2 6 would be how we might record our thinking there, okay? And see how we've moved. So then the next player would flip over their card, and trust me, it doesn't always come up as 1. Let me do. For some reason today it is. There we go.
You got the stacked deck.
Yeah, the stack deck. So there. I've played this multiple times and that has not happened, but of course it would do it today. So, but there's another card and how we would do it. Okay. So, and then we would just go from there. So any questions about that or comments about?
Lisa, I was noting again how how the number line is again another powerful tool. We keep coming back to that in our conceptual understanding of fractions is, of course, one of the recommendations from our IES document. But there it is in a number line-ish kind of way for kids to be able to think about it in terms of that. So nice.
Yeah, so there is that linear model too to think about it. Okay, and nice. Okay, so there's. Okay, having to do a little shifting around here. And they also have that same game, except rather than going to building to 1, this one is building to 2. So it is the same principle, but they are using mixed numbers and building to 2 in this game. So, and that is linked right there in the presentation. And I have the worksheet that goes with this as well. So you might take a little quick look at how that goes. So the same thing, we would place our markers, which I'm not going to take the time to do that, but we'll put over a card. And so how would we do that to move to get to 2? And place it in our collection box.
We can do fifths or not, or tenths.
Yeah.
I'm curious, Lisa, does it force you to only play on one of the tick marks, or are they just?
You know what? I did not try to put it like, do you mean like that? I could
Yeah.
put it there.
Okay, I was curious.
But I think the directions ask you to place a counter on each line to be your starting point.
Okay.
And then you go from there to add on or subtract to get to 2. And once you have completed to 2, then you get to put it in your collection box. So
Right.
if you're playing with someone, I guess your goal is to have the most counters in your box. And again, the directions are in that drop down right there. And the worksheet is linked on the page as well, and it'll be in our handouts. Navigating. Okay, awesome. Okay, so when we think about what we're doing with students and our instruction, okay, and when you think about even adding fractions, subtracting fractions, or even sometimes when we think about fractions, it causes people to have a little bit of anxiety, like, how do I deal with fractions? Okay? And so we want students to have that strong foundation so that they're not getting lost in the weeds of what do I do? I know when I talk to adults, that's what we think, like, oh, I can't remember. Am I supposed to invert and multiply? What am I supposed to do with these fractions? I don't remember how to do all this. So we want kids to have that firm foundation so that they know, like Dee said the other day, that these are numbers. We don't have to just do something to them. We can think about them and we can reason with them. So one of our research tools is the Van de Waal series. So Van de Waal gives us this nice example where if we have 5/6 minus 1/3, how can kids think about that in a conceptual way? So this is a nice visual that shows us how we might be able to illustrate that in that model. So that 5/6 of a rectangle looks like this. 1/3 looks like this, and the holes are the same size. So if we place the 1/3 piece over the 5/6, then there are just 3/6 left. So one thing that Van de Waal tells us that is important, and it's an important question for us to ask students, is rather than saying, what's the common denominator, to get kids to focus on what equivalent fraction might we use so that we have equal sized parts. Okay. So thinking about that, rather than just finding the common denominator, can put the focus on what are the size of the parts. Okay. And Van de Waal also had a nice progression as we're introducing these things to students. As we're moving from the materials to symbols and thinking about things in only a symbolic way, we want to begin with tasks where only one denominator has to be changed. We don't want to begin with ones where we have to think about changing both denominators, but an example might be 5/8 plus 3/4. We could change that 3/4 to 8ths by thinking about how can we make these where the pieces are the same size. Okay, so that key question is, how can we change this problem into one in which the parts are the same size? And then once we can do that, then we continue to examples in which both fractions need to be changed. An example of that would be the 2/3 minus 1/4. But I love that key question, thinking about the size of the parts.
Jennifer typed in the chat box that she also loved that question and that it connects to previous fraction learning. And I would add that's always a good idea.
Yeah, yes, I love the progression and how it builds. So if we have laid that foundation, as we've talked about throughout the week, then kids can, it's just a natural progression to build on what they already know. Okay? And it doesn't have to be anything scary. And they don't have to get lost in the weeds of, what did my teacher say to do? What rule do I have to remember? Okay? They can think about things and think it out. Okay. There is a nice little fraction progression that is from illustrative mathematics that we're going to take a moment to watch. I'm just going to be looking at the portion that is adding unlike denominators. So I'm just going to try to click through here. And if you wanted to go back and watch this whole thing, it would probably be well worth your time. However, I'm just going to move it to the section I want to see that addresses
or denominators. The sum of 3/4 and 2/3 is represented in the diagram in the same way that we represented 3/4 plus 2/4, but it isn't clear what fraction it represents besides 3/4 plus 2/3. With a little more work, we can figure this out. If we partition the fourths into 3 equal pieces, and then the thirds into 4 equal pieces, we haven't changed the numbers, just the way we named them. Now all the pieces will be the same size, and they represent twelfths. So now we can see that 3/4 plus 2/3 is 17 twelfths. Fifth grade is when students understand and explain why we find a common denominator when we add fractions with different denominators. Let's go through another example. If we want to add 1/2 and 3/5, we can partition the halves into 5 equal pieces to see that 1/2 is the same as 5/10. Then we partition each fifth into 2 equal pieces. And see that 3/5 is the same as 6/10. If we put all the tenths together, we see that we have 11/10. To add fractions with unlike denominators, we rewrite them as equivalent fractions with the same denominator so that the unit fractions are the same size. In general, if we...
Okay, so I'm going to just stop right there because I think that is the gist of it. I like that video because it shows visually what is happening when we're finding common denominators and why do we do it. And I think that is very powerful for me because, as it turns out, I'm a visual learner and I really like that. So that is linked in the presentation. So if you want to go back and watch that whole fraction progression, you can. It's about 5 minutes, but I really like that part about the demonstration of unlike denominators and how we put them together.
I'm going to pull a couple of things out of the chat, excuse me, because all kinds of people are like, oh my gosh, I wish I had seen this before now. I wish I had that when I was taught. It's not too late to go back and learn that stuff. So I'm so glad you got to see that. But also, this is why we do those procedures, right? So if you are having a hard time because we were all taught procedurally, seeing how that fits, this is really good for that.
Yes, I know. And if you wish you had learned it that way, I'm in that same boat with you because I can remember the feeling especially in middle school of, what are all those rules? What did my teacher say to do? I can't remember. And if I had had a visual model, it would have been immensely helpful.
Lisa, I remember the day that one of my middle school teachers said, why are you doing all of this? 4.5 divided by 1/2 is just how many halves in 4.5. You know how many, and I remember the way that they said it just made such sense to me. And it's the same thing with this. Like, why are you making a common denominator when 1/2 plus 1/4 is just 3/4? Have a picture in your mind.
Right. Yeah. Yeah. So it goes back to that number sense, right? Having number sense and thinking about fractions as numbers, not just symbols that we have to do something to. So that's our goal for students, to have that understanding. Okay, I do have a list of some resources on a resource page that have some links. There are so many that I found once I started digging in and trying to find some things, but I'm not sure for the time. I'm just a little bit over time. I'm just going to click on it just real quickly, just to give you an idea of the plethora of things that are out there. This links to that Howard site that I was telling you about, and that fraction standard that we're looking at. They have a list of the preferred task. Look at all those things that are there. All kinds of things that you can click through to find there with like denominators, unlike denominators, and fractions with mixed numbers. There's the Hershey bar activity that we took a look at is listed there. Okay? And they even have some additional resources. Van de Waal's at the top of their book list, but there's some additional tasks that are down through here that are all kinds of things that you can find. So if you're looking for fraction things, there is a nice resource for you. And let me go back to, sorry. And also the Georgia Standards Framework. Some of the schools that I visit use this as part of their curriculum. And their 5th grade unit 4 is at adding, subtracting, multiplying, and dividing fractions. And all those different things that you can just click on, and it takes you right to those activities. So lots and lots of things that you can find. And we try to, I guess, curate this for you so that you can find it here. So I wish I had more time to go through all of those things, but our time is up, and you guys can, if you're trying to build your fraction library, there is a nice resource for you to find some more activities. And there's a lot of rich tasks that you can do there, located there. So, and the investigation games that we took a look at, the fraction tracks link is right here at the top. So before we wrap things up completely, let's think back to our question at the beginning. Is it always, sometimes, or never true that we must find common denominators first to add and subtract fractions? Would somebody like to unmute and talk about that just a minute to wrap things up? What is your opinion now?
I missed the beginning of the session, maybe the first 10 minutes, but just from what I've been able to capture today, initially I think I would have said yes, but at this time I don't believe, because you have ways to manipulate visuals where you wouldn't necessarily have to change it, but you could visually see what it would equal without manipulating the numbers.
Yeah, and so I would tend to agree with that. So if it was always, sometimes, or never, I would think sometimes. And I think I see that in the chats, people are saying sometimes, depending on the situation, depending on the numbers that you're using, sometimes we can reason through it. And if we remember back to what our standard said, the standard said we want kids to be able to use visuals, models, that sort of thing, to do some reasoning, to think about it. So sometimes we don't have to go to that pencil, paper, butterfly method. You might have thought, oh, we're doing, unlike denominators today, we're going to be talking all about the butterfly method. You guys didn't hear the butterfly method once, did you? So, because I want kids to know and understand what they're doing when they do that. So we've got to lay that foundation first. So nice. Okay, so we're going to continue our focus on fractions tomorrow with fraction operations of multiplication and division. So I hope you'll join us then. And as I said earlier, we've got geometry and multiplicative thinking coming up later on. So there's my contact information, and be glad to chat with anybody that wants to chat. Thank you guys for joining us today. We really appreciate it.
Lisa, we thank you so much for sharing your expertise today. If a couple of you guys wouldn't mind unmuting and telling Lisa some of the favorite things that you saw from today's session.
Love the visuals in the chat, and thank you. This is awesome. Plan to share it with other teachers.
I always like the literature connection too. I think that was great. And I also like the Jamboard. I think that was Jamboard that you all were using again. Yeah, there was a lot of things, but I just think that I know that in our testing in Texas that when you really look at how it's tested too, most of the problems can be, I mean, like I would say 99.9% of the time can be reasoned through, and they don't have to quickly go to some sort of, you know, thing that doesn't make sense to them. So I really believe strongly, particularly at elementary, that all fractions should just be in the reasoning realm. And y'all did a great job. She did a great job today of staying in that wheelhouse of let's reason through this. Let's not get into something that doesn't make sense. So thank you.
Thank you.
Jennifer, we appreciate our friends from across the nation. Just today, we have actually we have 5 states represented. And so we are so glad that you guys join us from across the nation. And of course, our Kentucky friends are ones that we have been with us for a long time. So we're glad some of you guys have found us. Indeed, from the Kentucky Center for Mathematics, our mission and vision is to promote conceptual understanding of mathematics at a deep level. Those are the things that we talk about. Those are the things that we believe in. We've seen it in classrooms, in action with children, making a difference toward this deep understanding. So from the Kentucky Center for Mathematics, we appreciate you spending time with us this afternoon. Join me tomorrow. I'm going to be talking about multiplication and division of fractions. I too will be talking about the conceptual understanding and building from multiplicative and multiplicative reasoning. So it's going to look just like what we had when we were building multiplication understanding, but this time we're using the number fractionals. The numbers will be fractions. So thank you. See you tomorrow afternoon.
Thanks everybody. Have a great day.